On March 11, 2026, a paper was published in the journal Nature. It was not a long paper. The data it contained had been collected over 200 days by a global network of 27 telescopes watching a single supernova, a stellar explosion approximately 1 billion light-years from Earth, designated SN 2024 AFAV. The supernova itself had been discovered in December 2024. For 200 days, it did something that no supernova in recorded astronomical history had ever done before. It chirped, not audibly, not as a sound wave traveling through space. There are no sound waves in the vacuum between galaxies. The chirp was in light, a pattern of 4 oscillating brightness peaks in the supernova's fading glow, each one arriving faster than the last, the frequency accelerating like a bird call increasing in pitch, like a spinning top that wobbles faster as it slows, like, the researchers noted with unusual precision, a gravitational wave signal from 2 merging black holes. The same mathematics, the same shape, now found inside a dying star. When the team ran the numbers, there was only one explanation that fit. Hidden inside the supernova debris, still spinning, still accelerating, still generating the most powerful magnetic field in the observable universe. A magnetar had just been born. Not discovered, not inferred from ancient data, not predicted by a model and confirmed decades later. Born in real time, watched, the universe making its most extreme object and 27 telescopes catching it in the act. The Aegis has been to extreme magnetic environments before. The Neutron star episode, the field strong enough to restructure atomic orbitals, rearrange chemistry, pull iron out of hemoglobin. That was a standard pulsar. Rotating magnetic field, perhaps 10 trillion Gauss. A magnetar's field is 1,000 times stronger, not 10% stronger, not twice as strong. 1,000 times the field of the most magnetic, regular neutron star. The kind of field where physics itself changes, where the vacuum is no longer empty, where the space between atoms becomes a different kind of space. The suit will go where SN 2024 AFAV was, to the moment of the magnetar's birth, inside the supernova that created it, at the instant when a collapsing stellar core became something the universe had been hiding from human observation for 20 years. Could you survive the birth of a magnetar? You need to understand what you are entering. Not our sun. Our sun will never produce this. Begin with a star 25 times the mass of the sun, burning hydrogen, then helium, then carbon, then neon, then oxygen, then silicon at the core. Each fuel burned faster than the last. Silicon burns for approximately 1 day. Then the core is iron. Iron cannot be fused. The reaction stops. The core, a sphere of iron roughly the size of the Earth, collapses. In less than 1 second, it falls inward. The outer layers of the star, still falling, hit the rigid surface of the collapsed core and bounce outward. The bounce, a shock wave moving outward through the star at a fraction of the speed of light, ejecting the stellar envelope into space. This is the supernova. What remains at the center is not empty space. It is a neutron star. The collapsed core, now compressed to roughly 10 miles in diameter, with the mass of the sun packed into a sphere the size of a city. The density? Approximately 400 million tons per cubic centimeter. A teaspoon of neutron star material weighs more than all of human civilization combined. Now spin. The original star was rotating. Conservation of angular momentum, the same physics that makes an ice skater spin faster when pulling in their arms, takes that slow stellar rotation and amplifies it as the core collapses from the size of the Earth to the size of a city. The result? A neutron star spinning hundreds of times per second. The Magnetar, born inside SN 2024 AFAV, had a spin period of 4.2 milliseconds. It completed a full rotation 238 times every second. Now, the magnetic field. The original star had a magnetic field. Compressing it into a sphere 10 miles across amplifies it by factors of billions. A standard pulsar's magnetic field is perhaps 1 trillion Gauss, a trillion times stronger than Earth's. The Sun's surface field is about 1 Gauss. A refrigerator magnet is about 50 Gauss. The strongest laboratory magnets ever built by human technology reach approximately 45 Gauss sustained, with brief pulsed fields approaching 3,000 Gauss. A pulsar, 1 trillion Gauss. A magnetar, 100 trillion Gauss. 300 trillion Gauss. The magnetar in SN 2024 AFAV, estimated at 300 trillion times the strength of Earth's magnetic field. At this field strength, physics changes. The vacuum itself, the space between particles, becomes birefringent. Light traveling through it does not travel as it does through empty space. The photon's path is bent, its polarization rotated, by the magnetic field alone. This is not a theory. It has been observed in other magnetars. The field is strong enough to affect the structure of light. At field strengths above approximately 4 billion Tesla, the quantum critical field, the vacuum itself breaks down. Electron-positron pairs spontaneously appear from nothing, extracted from the vacuum by the field energy alone. The space around the magnetar is not empty. It is populated with particles that did not exist a moment ago and will cease to exist a moment later, continuously created and destroyed by the field that called them into being. This is the environment the suit will enter, not a strong magnetic field. The environment where the field itself creates matter from nothing. The magnetar is not accessible directly. It sits at the center of a supernova explosion. The debris field of SN 2024 AFAV, the stellar envelope ejected by the bounce, now expanding outward at a significant fraction of the speed of light, surrounds it. This debris is not thin. It is solar masses of stellar material. Hydrogen, helium, carbon, oxygen, silicon, iron, all of it ionized, all of it moving outward. The outermost layers already separated from the core by light minutes of hot plasma. This is the environment that confused astronomers for 20 years. Superluminous supernovae. Stellar explosions 10 times brighter than ordinary ones were discovered in the early 2000s. They were too bright. The standard supernova model could not account for the energy output. Something was powering them from the inside, continuously, long after the initial explosion should have faded. For 2 decades, the leading theory was a magnetar, the spinning magnetic field accelerating charged particles that slam into the expanding debris from the inside, acting like a continuous bellows, keeping the fire burning. But no one could see it. The debris was opaque. The Magnetar was hidden behind solar masses of stellar material, its presence inferred only from the energy budget, from the brightness that could not be explained any other way. The Magnetar existed as a theorist's inference, not an observer's fact. SN2024AFAV changed this not by becoming transparent, but by chirping. The suit descends through the debris field. The temperature, 10,000 degrees in the outer layers, increasing as the suit moves inward toward the center. The density, not the vacuum of interstellar space, but not the crush of a stellar interior either. The supernova debris is expanding, thinning, becoming progressively less dense as the shockwave moves outward. The suit's thermal systems register continuous and significant load. The suit's particle detectors register a continuous storm of relativistic particles, the charged particles being accelerated by the Magnetar's field, slamming into the debris from the inside, heating it, pushing it outward, powering the brightness that can be seen from 1 billion light years away. The particles come from below, from the center, from something the suit is moving toward. At some point in the descent, the suit's magnetic field sensors go from maximum to something that has no maximum. The instruments were calibrated for strong magnetic environments. The Neutron star episode was calibration level. What registers now is not a reading, it is a saturation. Every magnetic sensor pegged at the high end of its range and climbing. The suit adjusts. New calibration mode. The instrument's designed for fields above pulsar threshold. The Magnetar is approximately 1 light second away. At a safe distance, if safe is a meaningful concept, the suit's systems analyze what the field is doing to the space around it. The first effect is on the photons. Light emitted by the supernova debris passing through the region near the Magnetar is polarized and rotated by the field. The polarization changes with distance from the Magnetar, not smoothly, but in the specific pattern predicted by quantum electrodynamics in strong magnetic fields. This is vacuum birefringence. The empty space near the Magnetar is optically active. Light is being bent and polarized by a field, not by matter. The suit's optical sensors can see it. The light arriving from the direction of the Magnetar is not the same light that left the debris. It has been reorganized by the field it passed through. The second effect is on the suit's hull. The exotic matter shielding, the material that has survived neutron star surfaces, Venusian acid, the plasma of the Big Bang, registers something that is not temperature, not pressure, not particle impact. It registers magnetic stress. The field is trying to restructure the material itself, not heat it, not compress it. Reach into the atomic structure and reorient the electrons. At 300 trillion Gauss, the electron orbitals of every atom in a conventional material are restructured. The electrons no longer occupy the spherical probability clouds of normal chemistry. They are compressed into long, thin cylinders aligned with the magnetic field. The atom itself changes shape. The chemistry that holds molecules together no longer works the same way. Materials that are solid at any other temperature or pressure become a different kind of solid. Magnetically confined, field-dependent, existing in a state that has no name in human chemistry because human chemistry has never encountered a field strong enough to cause it. The suit's exotic matter hull is designed for exactly this. It does not restructure. It holds. The third effect is on the space itself. The quantum critical field, approximately 4.4 times 10 to the 13th power Gauss, is where physics changes most dramatically. Below this threshold, strong magnetic fields, significant effects, but space behaves like space. Above it, the vacuum energy is sufficient to spontaneously produce electron-positron pairs from nothing. The field reaches into the quantum vacuum and pulls particles out of it. The suit is now surrounded by a continuous creation and annihilation cycle. Particles appearing from empty space, colliding, annihilating back into photons. Those photons creating new pairs. The cycle continuous and energetic, and generating a radiation environment that has no analog anywhere else in the observable universe. The suit's radiation sensors, calibrated for supernova surfaces, for neutron star magnetospheres, saturate. The calibration adjusts upward. The numbers stabilize that have no reference point in the mission library. HUD, ambient radiation environment, quantum critical field regime. Vacuum pair production, active. Energy flux exceeds mission library reference. Status, managing. The suit is managing. Barely. The accretion disk is the reason SN 2024 AFAV could be identified. As the supernova explosion expanded outward, not all of the stellar material escaped. Some fell back inward, drawn by the gravitational field of the newly formed Magnetar, unable to overcome its own momentum to escape. This material formed an accretion disk, a ring of stellar debris orbiting the Magnetar, spiraling slowly inward. The disk was not symmetric. It could not be. The explosion was not perfectly symmetric. The material did not fall back evenly. The disk was misaligned with the Magnetar's spin axis. And here is where general relativity appears in a supernova for the first time in the history of physics. The Magnetar spins. A spinning mass, according to Einstein's theory of general relativity, drags the space-time around it, not the matter, but the space itself, into co-rotation with the spin. This effect, Lense-Thirring precession, is measurable near Earth. It was confirmed by Gravity Probe B in 2011 with great difficulty because Earth's effect is tiny. Near a Magnetar spinning 238 times per second with a mass greater than the Sun, the effect is overwhelming. The misaligned accretion disk, sitting in space-time that is being dragged into rotation by the Magnetar, wobbles, not randomly, not chaotically, regularly, in a specific pattern determined by the disk's mass, its distance from the Magnetar, and the Magnetar's spin. The wobbling disk periodically blocks the Magnetar's light from reaching the outside, then reflects it, then blocks it again. A strobe, a lighthouse, a chirp. As the disk spirals inward, its distance to the Magnetar decreases. Closer disk wobbles faster. Faster wobble, the chirp frequency increases. 4 oscillations, each arriving faster than the last. The sound of an accretion disk dying, falling into the most magnetic object in the universe. The suit is inside this disk. The material around the suit, the falling stellar debris spiraling inward, is not dust. It is plasma at millions of degrees, threaded by magnetic field lines that connect it to the Magnetar below. The field lines do not allow the plasma to move perpendicular to them. The plasma is constrained to move along the field lines, spiral along them, be accelerated along them. The suit is in a river of magnetized plasma moving in 3 dimensions simultaneously, falling inward, spiraling with the disk rotation, and wobbling with the Lense-Thirring precession. The wobble is not smooth. It is the suit's frame of reference that is wobbling. The space-time itself, dragged by the Magnetar's spin, is rotating around the suit faster than the suit can track. The suit's navigation systems, calibrated for flat space-time, for the standard general relativistic corrections near ordinary stars, register a continuous and accelerating frame drag. The correction algorithms update continuously. The suit does not know which way is down in the ordinary sense, because in the strongly curved space-time near the Magnetar, the ordinary sense of down is not stable. HUD. Frame drag. Significant. Lense-Thirring correction. Active. Space-time curvature. Beyond solar system reference. Navigation. Relativistic mode. You are wobbling with the disk. The disk is telling the universe where the Magnetar is. And 27 telescopes, 1 billion light-years away, are recording the chirp. The suit survives. You would not. Not because of the temperature, though 10 million degrees in the accretion disk would vaporize every biological molecule in your body before any other effect had time to manifest. Not because of the pressure, though the density of the accreting material would exceed anything your body has structural integrity to resist. Not because of the radiation, though the quantum critical field radiation environment would deliver a lethal dose in microseconds. Those are the immediate causes. The fundamental cause is the magnetic field. At the field strength near a magnetar's surface, the human body cannot exist as chemistry. The carbon-carbon bonds that form the backbone of every organic molecule are based on electron orbital geometry. The electron orbitals of carbon, nitrogen, oxygen, hydrogen, the 4 elements that make up 99% of you, are spherical or lobed in normal conditions, allowing the directional bonding that creates proteins, nucleic acids, lipids, every structure in your biology. In a 300 trillion Gauss field, those orbitals are cylindrical, aligned with the field, not spherical, not lobed, tubes pointing in one direction, unable to form the directional bonds that chemistry requires. You are not crushed. You are not melted. Your atoms are rearranged at the quantum level into a configuration in which biology is not possible. Not destroyed, restructured. Your atoms remain. Your chemistry ceases. This happens at the speed of the magnetic field's propagation, which is the speed of light. There is no warning, no sensation, no moment of heat or pain before the restructuring. The field arrives at the speed of light, and at the speed of light, the orbital geometry that makes you alive is replaced by the orbital geometry that makes you a cylinder of magnetically confined matter. The distance at which this occurs depends on the specific field geometry of the magnetar in question. For SN 2024, AFAV's magnetar, 300 trillion times Earth's field, the threshold for orbital restructuring begins to become significant at distances of thousands of kilometers from the magnetar's surface. You would not need to approach the surface. The surface would not be your problem. The space around the magnetar would be your problem, long before you were close enough to see the surface. The suit's exotic matter hull is designed to maintain structural integrity in restructured field geometries. The atoms of the hull maintain their bonding configurations against the field. The suit holds. You are not made of exotic matter. The birth of the magnetar was observed for the first time in March 2026. But this is not primarily a story about what a magnetar does to your body. It is a story about what the magnetar's birth reveals about everything else. For 20 years, superluminous supernovae were the universe's most expensive mystery. They were 10 times brighter than ordinary supernovae. They stayed bright far longer than any model could explain, And they appeared to be powered by something invisible, something hidden behind the debris of the explosion itself. Dozens of explanations were proposed. Most were wrong or incomplete. The Magnetar theory, proposed by UC Berkeley physicist Dan Kaysen 16 years ago, fit the energy budget but could not be confirmed. You cannot see the engine if the engine is buried under solar masses of ejecta. SN 2024 AFAV found a way around this problem that no one had anticipated. Instead of seeing the Magnetar directly, it let the Magnetar's geometry speak. The wobbling accretion disk, driven by general relativity, visible in the light curve as a chirp, carried the Magnetar's properties encoded in its frequency and timing. The spin period, 4.2 milliseconds. The magnetic field, 300 trillion Gauss. The mass, greater than the Sun, compressed to 10 miles. All of it inferred from the shape of 4 brightness oscillations in a supernova 1 billion light-years away. This is the first time that general relativity has been required to describe the mechanics of a supernova explosion. General relativity was needed to describe the chirp. Without Einstein's 1915 theory of general relativity, the prediction that spinning masses drag spacetime, the 4 brightness bumps in SN 2024 AFAV would have been unexplained, or explained by a wrong model, or dismissed as noise. This matters because the Magnetar is not unique. Farah and his collaborators estimate that many, perhaps most, superluminous supernovae are powered by magnetars at their centers. SN 2024 AFAV is the first to show the chirp. It will not be the last. As the Vera C. Rubin Observatory comes online and begins surveying the sky with unprecedented completeness, astronomers expect to find dozens of similar chirping supernovae. The chirp will become a diagnostic tool, a way of measuring the spin, mass, and field strength of a magnetar hidden inside any superluminous supernova that shows it. The universe has been making magnetars for as long as massive stars have been exploding, which is almost as long as there have been stars, which is almost as long as there has been a universe. Somewhere, right now, as you read this, massive stars are collapsing. Cores are bouncing. Neutron stars are forming, spinning up, acquiring magnetic fields 1,000 times stronger than any pulsar. Accretion disks are forming, wobbling in dragged spacetime, chirping in light that will take billions of years to reach any telescope. We watched it happen for the first time in March 2026. 68 days of observation by 27 telescopes. 1 chirp, 4 bumps. One graduate student, Joseph Farah of UC Santa Barbara, who noticed that only general relativity fit the timing, and the magnetar, still spinning, still radiating, still accelerating particles into the debris that will expand outward for millions of years, and eventually, 1 million years from now, 100 million years from now, become the interstellar medium that will condense into new stars, new planets, new chemistry. The atoms in you were made in a stellar explosion. Not necessarily a superluminous one, not necessarily powered by a magnetar, but the same physics: core collapse, bounce, neutron star formation, the conservation of angular momentum amplifying a spin, the collapse amplifying a magnetic field, produced the heavy elements that make up your bones and your blood. You are not separate from what SN 2024 AFAV produced. You are a delayed consequence of the same process. The chirp in SN 2024 AFAV was the sound of creation. Not metaphorically, literally. The creation of the most magnetic object in the universe out of the collapse of a star, broadcasting its existence in a pattern of light that required general relativity to decode. The suit returns. The accretion disk continues to spiral inward. The wobble continues to accelerate. Somewhere in that debris, 1 billion light-years away, a magnetar is still spinning, still threading space with a field 300 trillion times stronger than Earth's, still dragging space-time into its rotation, still pulling matter from the disk and accelerating particles outward. It will do this for thousands of years. Then the disk will be gone. The supernova debris will have expanded too far to fall back. The accretion disk will exhaust itself, and the chirp will stop, and the magnetar will be left alone, spinning, radiating, slowly decelerating over millions of years as its field dissipates its rotational energy. Eventually, it will become a pulsar. Then, over billions of years, a cold, dark neutron star. Undetectable, invisible, drifting through the intergalactic medium with the angular momentum of a star that died billions of years before. Everything that SN 2024 AFAV will ever be, it is already becoming. We caught it at the beginning. 4 tones, each arriving faster than the last, in a room with 27 telescopes watching. The universe making its most extreme object, and, for the first time, being watched. Could you survive the birth of a magnetar? The magnetar survived its birth. The universe survived the process that made it. You are the product of a version of that process. Less extreme, less magnetic, still violent, still the same physics, running in a star that died before the Earth existed. You did not survive the birth of a magnetar. You are the echo of a birth that was similar enough to matter. What should the Aegis face next? Should we go to the magnetar's surface, where the field is strong enough to restructure atomic orbitals at a distance? Where the crust is the hardest material in the universe? Where starquakes release more energy in a fraction of a second than our sun emits in 100,000 years? Or should we enter the superluminous supernova itself? Not the moment of magnetar birth, but the peak of the explosion, when SN 2024 AFAV shone brighter than 10 billion ordinary stars. Vote in the comments, and subscribe to Could You before the chirp reaches you.